Oke, sekarang mari kita bicarakan lagi tentang wahana yang lebih berat dari udara. Tadi semuanya adalah yang lebih ringan daripada udara, ya. Jadi bentuknya airship ya. Anda juga nanti bisa bikin autonomous airship lah. Semacam itu teknologinya. Coba mungkin siapa tahu di tugas akhir atau di kerja praktek ya atau penelitian ya, Anda bisa arahkan ke sana. Lalu sekarang sebagai wahana lebih berat dari udara, pesawat ya. Ya contohnya nih ya, pesawat N219 yang tahun 2020 kemarin sudah dapat surat sertifikatnya ya dari Departemen Perhubungan. Jadi sudah bisa diproduksi dan sudah boleh jualan intinya di Indonesia. Ya, kita coba pelajari kenapa pesawat bisa terbang. Ya, mungkin ini standar. Seperti tadi disebutkan ada 4 gaya. Ya, how do airplane fly? Ya, pada dasarnya Anda sudah tahu lah basic-basic gayanya. Tapi kita review lagi apa yang belum terjelaskan ya sebelumnya.
Modern airplanes are truly engineering marvels. They overcome highly turbulent and unpredictable currents in the air and complete their flights by undertaking many complex maneuvers. Have you ever thought of how the pilots are able to achieve this? Or what happens to the airplane when the pilot operates certain controls? In this video, we will explore how an airplane flies and how pilots are able to control an airplane in a logical yet simple way. We thank SimScale for lending their CFD support and making this video more informative.
Anda perhatikan ini bagus iklannya, SimScale. Nanti akan Anda pelajari ini software untuk menganalisa CFD, ya, aerodinamika, untuk menganalisa struktur, untuk menganalisa thermal, ya dari cloud computing. Ya, ini software yang pertama di dunia yang menyiapkan cloud computing untuk kita-kita yang mempelajari di Dirgantara. Ya, jadi perhatikan Anda belajar sudah mulai bisa pakai server orang lain lah tanda petik. Ya, oke kita perhatikan bagaimana cara pesawat dikemudikan.
First, let's have a closer look at modern airplanes' wings and tails. One interesting thing you will notice is that they are not made as a single solid piece. The wings and tails of the airplanes have many movable parts. The most fascinating thing about the whole wing and the different parts of it is that they form a very special shape in fluid mechanics. That is the airfoil shape. Just by understanding the physics behind this simple shape will allow you to completely understand airplane physics. Let's learn more about airfoils. An airfoil produces a lift force when moved relative to the air. This lift force makes an airplane fly.
Anda tahu kenapa airfoil menghasilkan lift, menghasilkan gaya angkat? Ya mungkin nanti Anda belajar di aerodinamika, tapi prinsipnya harus airfoil. Ya, kalau nggak airfoil nggak ada gaya angkatnya. Nah, yang harus diperhatikan kenapa bentuk seperti ini menghasilkan gaya angkat. Ya, Anda perhatikan.
How is this lift produced? The airfoil produces a downwash as shown. This causes a pressure difference at the top and bottom of the airfoil, and hence produces lift. This high-quality CFD analysis using SimScale software clearly illustrates this fact. Generally, the higher the angle of attack, the greater will be the downwash, and therefore the lift force. A greater airspeed also increases the lift force significantly. Interestingly, in mankind's first successful flight, the Wright flyer also made use of this same airfoil principle. Even though their airfoils were a simple curved shape, it was sufficient to produce a good downwash. More specifically, their airplane had 2 such airfoils. One more idea to increase the lift force is by altering the airfoil shape like this. The alteration in shape will definitely increase the downwash and the wing area, hence giving greater lift. In short, there are 3 techniques to increase the lift of an airfoil. Let's apply this airfoil knowledge.
Ya, ingat-ingat ada 3 cara untuk menghasilkan gaya angkat. Pertama, ada kecepatan. kedua harus ada sudut serang, ya. Dan yang ketiga itu tadi harus ada perubahan bentuk, ya, supaya lebih aerofoil. Ya, perubahan bentuknya caranya gimana? Terutama dengan merubah flap atau slat. Ya.
To the airplane. If we activate the flaps and slats, it increases the downwash and increases the lift. The ailerons can move up and down, and for that reason, the lift force can decrease and increase respectively. At the tail of the airplane, you can see two attachments, the rudder and the elevators. By adjusting the elevators, you can control the vertical force on the tail. By adjusting the rudder, you can control the horizontal force. Now, let's get into the most interesting part of the video, controlling the aircraft using these simple wing attachments. Let's start with the takeoff part of the flight. To get the airplane to take off from the ground, what you have to do is increase the lift force using various techniques and make sure that this force is more than the gravitational pull. Pilots apply all of the three lift increase techniques together for a successful takeoff. First, the speed of the airplane is increased by increasing the thrust of the engines. When the airplane's speed is high enough, the pilots activate the flaps and slats. Lift is further increased due to this. When the airplane is ready for takeoff, they activate the elevators upwards. The tail force tilts the airplane as shown, and the angle of attack of the airfoil will be increased. The lift is suddenly increased due to this, and the airplane takes off. Usually, an angle of attack of 15 degrees is maintained for the takeoff. In all these discussions, we are talking about the engine's thrust. But how is the engine able to generate thrust? Modern airplanes use special kinds of engines called turbofan engines for this purpose. In this, the fan's reaction and the reaction force of the exhaust give the necessary thrust force. By burning more fuel, the pilot can achieve more thrust. The fuel of an airplane is stored inside the wings. After the takeoff, next comes the climb phase of the aircraft. As long as the engine's thrust is more than the drag, the speed of the airplane will keep on increasing. The greater the speed, the higher will be the lift force. This will cause the airplane to go up. When the airplane reaches level flight, there won't be any acceleration or change in altitude. You can see that with this condition. The thrust should be exactly equal to the drag, and the lift should be exactly equal to the weight of the airplane. Now, let's discuss the most crucial part. How does an airplane change direction? You might think that just by adjusting the rudder, you would be able to do this. The rudder produces a horizontal force, and this force can turn the airplane. However, such a direct change in direction will cause discomfort to passengers, and it is not a practical method. To make a turn as shown, what you need is a centrifugal force. Let's see how pilots achieve this centrifugal force. Pilots just make one aileron go up and the other aileron go down. The difference in the lift force will make the airplane roll. In this roll condition, the lift is not vertical. The horizontal component of the lift can provide the necessary centrifugal force to bank the aircraft. This way, the pilot can make a turn of any radius depending upon the angle of roll and the speed of the airplane. However, this banking technique has some drawbacks. When you keep one aileron up and the other aileron down, the drag forces induced on the wings are not the same. This will cause the airplane to yaw. This phenomenon is known as adverse yaw. The rudder has to be operated simultaneously to prevent the adverse yaw. The way pilots control the different wing attachments and the whole airplane is illustrated in this animation. In practice, a control computer accurately manages all these wing attachments using a fly-by-wire system. To descend the airplane, what pilots do is decrease the engine's thrust and keep the nose of the airplane down. You can see this is exactly the opposite of the climb operation. As the airplane loses speed, it gets ready for landing. At this stage, the flaps and slats are activated again. These devices also increase the drag. To increase the drag further, a wing attachment called a spoiler is also activated. The pilots use one more trick here to reduce the stopping distance, which is reverse thrust. Here, the engine covers open wide, and the air which was supposed to go backwards is forcefully directed forwards. This will obviously generate reverse thrust and will make the stopping of the airplane easier. The CFD simulations we saw in this video were produced by SimScale, a powerful cloud computing-based FEA and CFD software.
Oke, jadi sekilas perjalanan gaya-gaya yang bekerja di pesawat seperti itu ya. Jadi dia bisa take off, dia bisa landing, dia bisa belok kanan, dia belok kiri dengan segala fasilitas yang ada di sayap dan siripnya. Nanti detailnya Anda tentunya akan belajar di aerodinamika, nanti Anda juga akan belajar di flight dynamic, mekanika tekniknya, dan pelajaran-pelajaran lainnya. Anda belajar navigasi, sistem kendali terbang, ya itu di semester-semester berikutnya. Tapi setidaknya Anda ngerti bahwa gaya-gaya itu yang bekerja di pesawat. Ya. Nah, bagaimana bisa terbang tanpa gaya dorong? Nah, ya, jadi nggak ada mesinnya ya bisa juga terbangnya. Seperti ini ya di glider, ya. Glider nggak ada mesinnya, dia bisa terbang lama. Makanya Anda lihat kalau glider itu pasti sayapnya panjang. Kenapa? Dia paling efisien secara aerodinamik. Ya, aspek rasionya tinggi. Sehingga aerodinamik sangat efisien. Jadi drag-nya kecil. Jadi kalau bisa glider itu terus saja putar-putar di atas, nggak turun-turun tuh. Ya, makanya glider-glider yang baru ada motor juga untuk nambah-nambah. Jadi bisa mungkin pakai sel surya, ya, sel matahari di sini untuk gaya motor tambahan. Tapi pada umumnya ya dia tidak ada motor, dia hanya glide aja. Ya. Ini contoh glider. Oke, kita lihat bagaimana dia bisa naik turun kiri kanan, ya, bisa dikemudikan glider.
This is a one-of-a-kind Tesla Model S Apex, and it could be yours. That's right.
The gliders, also known as sailplanes, are a kind of aircraft that differ from the rest by their ability to fly great distances without the need of an engine or propulsion of any kind, even gaining altitude during their flight. But how is this possible? That's what I'm going to answer today in this video. Welcome to Joy Planes RC2. Personally, gliders are my favorite aircraft because they don't need an engine to fly, and because of the long, impressive wingspan they have. But their long wings have a reason to be. Let's start with the basics. We know that an airplane can fly or glide without an engine, but in the process, it will gradually lose altitude, and depending on its weight, aerodynamics, and other physical facts, it can go down faster. This happens to every airplane, regardless whether they are gliders or not. Without an engine, it is possible to fly for some distance and land as long as a constant speed and descent rate is maintained to be stable in flight. But the gliders are designed to take full advantage of this balance of forces. Gliders are made with lightweight materials, and the weight is distributed at strategic points in an efficient manner to improve air penetration. And the configuration of their wings allow them to have more lift with less aerodynamic drag. As a result, their glide ratio is one of the most efficient among all airplanes. The glide ratio is the distance that the aircraft can travel in respect to the lost altitude. For example, a Cessna 172 has a glide ratio of 9 or 9:1, which means that if its engine stops, it can fly from 100 meters of height for about 900 horizontal meters. In modern gliders, this gliding ratio can be between 40:1 to 70:1, which means that if a glider has a 50:1 glide ratio, then it could fly for 50 kilometers if it starts flying from 1 kilometer high, making it capable of covering long distances in this way. Still, it is impossible to gain altitude for an aircraft that moves through a static atmosphere without the use of propulsion of some kind. Luckily, our atmosphere is not static at all. To gain altitude, gliders can take advantage of various atmospheric phenomena. There are three main phenomena: the ridge lift, thermals, and wave lift. Thermals are the most common mentioned way to gain altitude in a glider. These are columns of hot air that are generated by the surface heated by the sun. This air becomes less dense than the surrounding air and begins to rise rapidly. The glider, when entering a thermal, can begin to fly in a circular pattern to stay inside it and gain altitude until the thermal disappears or weakens. The other way to gain altitude is with a ridge lift. These are ascending currents of air on the slopes of the mountains. It's simply air that is forced to climb a mountain, and a glider can take advantage of this current to gain altitude. The closer to the slope, the stronger the climbing rate. The last kind of lift is the wave lift. It's about using the waves generated after the air passes through the mountain. These waves extend for several kilometers and are invisible waves similar to the waves on the sea. Using these strategies to gain altitude, a glider can stay in flight for many hours. This is totally free and clean energy that glider pilots gather and manage to get the most out of it. However, to make the glider take off, you will need an airplane that will tow it to an acceptable altitude where the glider can start by itself. Another way to take off is with a tow winch from the ground. But the altitude gained in this method is not as much as the first method. Hopefully, in a sunny day, the glider can take thermals and fly longer. Other ways to take off in a glider is from the mountains with a system of elastic ropes on a hillside, or by having a retractable propulsion system integrated into the glider that is only used to take off or gain altitude when needed. Why long and thin wings? The thin wings generate less aerodynamic drag than the common wings that are seen in self-propelled airplanes. In this way, the glider can pass through the air with less difficulty, obtaining the same lift and losing less speed than other airplanes. Another factor that helps for better aerodynamics is the design of the fuselage, making everything as smooth, thin, and aerodynamic as possible, which is why the pilot enters the cockpit in much the same way as a Formula One driver in his car, almost lying down. The wings are also measured by aspect ratio. Glider wings have a high aspect ratio, and war airplane wings have a low aspect ratio. War or aerobatic aircraft wings generate more induced drag than the thin wings of gliders, but because they are short wings, they are more maneuverable. Maneuverability is a priority in warplanes rather than fuel efficiency. In the case of the gliders, it is not necessary to make quick maneuvers, so the priority is given to efficiency, sacrificing maneuverability. That's why the wings end up being naturally long, because the large wing area is required with the restriction of a reduced chord wing to minimize the drag. Gliders are built to be very light but strong at the same time. They are even so light that you have to put more weight on the wings to improve their penetration and speed characteristics. This is done by filling the glider with water ballast in special tanks inside the wings. The total weight of this ballast can be even higher than the pilot's weight. The water can be drained during the flight in case the thermals are not so strong, and must be also drained before every landing. In the beginning, gliders were made out of wood with fabrics or metal, and then the use of composite materials like fiberglass, carbon fiber, and Kevlar was introduced, achieving a very huge structural resistance with very light weight. flight instruments. Gliders are equipped with the basic instruments that can be found on any other aircraft, except for the flight instruments associated with the use of an engine. The most used and necessary instruments are the anemometer, altimeter, variometer, and compass. You can also find a turn coordinator, sometimes an accelerometer, and tools like a radio and a GPS. One of the most basic indicators that are still used even in high-performance gliders is the yaw string. It is a small string, generally red, that is placed on the outside in front of the pilot that indicates the wind direction in regarding to the glider flight. If the string is not centered, it must be corrected using the rudder, and that way the pilot makes sure that he is flying efficiently. Otherwise, that means that the fuselage is off the course by some degrees in respect to the airflow, and that generates a lot of drag. It is important to be aware of the speed of the glider at all times, since if the glider gets too slow than the recommended speed, it can lose some control and also get into a stall. Also, depending on the design, there is a specific speed in which the glider has a maximum efficiency between descent and distance traveled. To measure the speed at which the glider is going, in respect to the wind, the anemometer is used. The airspeed is different from the ground speed. The variometer indicates the speed of climb and descent. This instrument is super important to know when the glider is beginning to climb, usually when enters a thermal, and thus stay within the thermal. The gliders are equipped with a system that generates a sound depending on the speed of ascent or descent. With this sound, you can more easily identify if the glider is going up or down without having to look at the indicator at all times. As you have already seen in this video, gliders are a very interesting type of aircraft, especially because they don't burn any type of fuel to stay in flight. They only use the natural energy available in the air currents. Nowadays, gliders are used for sports and recreational purposes. I give a special thanks to Stefan Langer.
Oke, itu tentang glider. Jadi memang glider terbang tanpa engine ya. Tujuannya untuk bisa terbang selama-lamanya di atas sana. Untuk rekreasi, sport, ya, hal semacam itu. Ya. Berikutnya adalah pesawat komersial. Tadi sudah bicara tentang balon, tentang pesawat biasa, tentang airships, ya. Terus tentang glider. Nah, sekarang yang komplit komersial, pesawat komersial. Ya. Pesawat komersial, ya bedanya hanya dia punya penumpang aja, sehingga keamanannya jauh lebih aman dibanding yang lain. Jadi sebelum dia terbang, persyaratannya panjang, ya, birokrasinya, kelayakannya harus diuji segala macam. Desainnya juga dari awal harus dibuktikan bahwa ini bisa desain sesuai dengan yang direncanakan. Misalkan buat penumpang ya, engine nih penting. Kalaupun aja mati satu engine, masih dia bisa terbang dengan engine yang ada. Itu persyaratan, harus terbukti secara desain dan secara uji. Ya. Yaitu pesawat komersial, paling banyak lah persyaratannya pesawat komersial. Makanya pengembangan pesawat komersial tidak begitu pesat, karena birokrasi pesawat komersial banyak aturannya.